Welcome to the Innovators podcast. Actually, the Innovators Insider podcast. It is quite an innovative podcast, I must say. But
and we're both insiders, so
and we are. I guess we are. Well, great show today. I've been looking forward to this for a long time. We have a legendary person from the CAD industry involved with surface modeling, industrial design. Richard's going to give him a great introduction, so I won't steal his thunder. We also have a great tech tip from my colleague, Jake Delano. So we're going to, enjoy, learning something about Onshape. So without further ado, maybe we should introduce our special guest.
Yeah, let's go ahead and do that. And just like you, I've been really excited about this. I've known our next guest for many years. He's a senior industrial designer with over 25 years experience, and he's spent 21 years now at the DiMonte Group, a product design and engineering firm up in the Chicago area. They offer a full line of integrated product design, product engineering, and development services. Our guest is a legend in the CAD industry, one of the go-to guys, go-to presenters for tech conferences, for local user group meetings, and just a really great guy overall. So let's welcome Ed Eaton. Hey, Ed.
Hey, everybody. That was a great intro. That was fun.
Well, I'm glad you liked it.
I hope I live up to it.
I've known you for probably 15 or 16 years. I could have gone on for another half an hour with the accolades. Always been one of my favorite people, and we're really happy to have you on the show. So,
well, thanks for saying that. Yeah. It's nice to be here.
Yep. So let's go ahead and get started. So the theme of our show today is consumer product design. We're kind of talking about consumer products, Industry 4.0, maybe some customization, things like that. As an industrial designer, when it comes to designing consumer products, what are some of the really important factors that always come into play?
There's a list of probably about 1,000 that I think of when I'm starting off on a project, and each one depends on the customer. So we're a product development consultancy, so we work across a number of different industries. A lot of it isn't consumer products. I'll tell you that straight up. A lot of it is sort of industrial or equipment manufacturing. I've done tons of restaurant equipment. I've done Pazload guns used on construction sites, things like that. But when so I don't know if you want to actually keep it to just consumer products, or if you just want to talk about general product design from an industrial designer's perspective.
Well, I guess that's the thing, Ed. From an industrial designer's perspective, everything is a consumer product, right? I mean, even when you're talking about industrial equipment, you have to have an operator. So you have to, certain ergonomic things that are involved with all of that. So yeah, absolutely. Let's broaden the scope of that.
And well, you've known me long enough. I get kind of into beefs with definitions that corral people in their thinking, because you're right that everything is a consumer product when you get right down to it. But you don't think about like airplanes as not that I've done those, but as a consumer product. But there's certainly somebody who's buying them and maintaining them. But when it comes to product development, it all starts off with whatever the customer's really looking for, whatever their financial need is and their economic need is. Sometimes it's, hey, we've got this great idea that we want to commercialize because we know we've got people that would be interested in it, or we know that it's an improvement that would really get people excited, and we could tap into that excitement. And we got to understand what are the factors that make that opportunity for our customers, so that we can steer what we're doing to best suit their needs. Sometimes it's just sketching. Sometimes they have an idea and they need insight into, hey, what are some processes that are appropriate for the quantity that I've got, and even for the amount of investment capital that I've got. I was doing a product a few months ago for a startup. It's a really cool product, and they're starting off in quantities of hundreds of it in a year, and their early prototypes are all fabricated and costing a fortune. So what can we do to kind of get them into the business with something that looks really nice, that's also is human friendly, that's lighter in weight, because weight was a concern with this thing, but also isn't going to break the bank, because their startup. They've only got so much capital, and they've got to get the ball running, or get the company running on the amount of money that they've got. So that was a sketching job. Sometimes it's a little bit of CAD. Sometimes it's starts off with as just a rendering job. Frankly, we did this one. Here we go.
This is great.
Yeah, years ago we did. We had a company that had developed a circuit tester, and they had a board, basic footprint for the board, and they asked us, well, what can we do to generate some images that were essentially fake to make the potential licensees think that this product was done and ready to go. The electronics were done and ready to go, but the housing itself was all virtual. But we did our usual process with it. We didn't want to show somebody something and then risk them being excited by it and buying it and having the industrial design be garbage. So we start off anything that we're going to have people touching with their hands, even if it's going to be an image in its first iteration of in its first month of life. We want to be sure that this thing is going to work functionally, so that when somebody's pushing this into an outlet, I've embedded the plugs, and then I've created undercuts so that we can remove it from the outlet. And we're doing this in the clay because I can do a concept in 2 hours, and I could do 5 or 6 different ideas and put them in the person's hands, and then they can decide which they want to do. And then I don't have the rendering handy. It's on our website buried somewhere. But then when they took it to Greenlee, and then they took it to Ideal, Ideal licensed it, and Ideal was like, hey, let's just use what you already designed. And then we had to make the housing design. But one thing we've learned, especially on the industrial design end, is even if we're just doing a pretty picture to get people's interest, we're always building draft in right at the beginning, because that's not something you want to be surprised about at the end. And you never want to be in a situation where you've presented a concept, they've accepted it, they've sold it to marketing sold it to the buyers, and then they're coming back and like, yes, it's time, let's make tool ready geometry. And you say, well, it actually can't look the way it is. That's, to me, that's professional malpractice. But it does happen, and there are reasons to do that in the industry. There's a bunch of stylists out there. They do great work. They get things moving, get new ideas started. But we tend to be just more mechanical because we are taking ownership all the way through the end. Now, some products, we already kind of know what it's going to be. Sometimes it's another industrial design firm that's developed this styling, and then we have to do that job of taking something that might not be manufacturable and then figure out how to manufacture it. And there's all sorts of different permutations of those factors, right? The best case scenario job is where we get to meet with the customer, where we get to do some preliminary research, and that research is not just having conversations with the customer, but hopefully getting to do on-site research. We really love it when we get to do ergonomic research for something, especially when it comes to tool design, because we don't want to model a handle on the screen, then 3D print it, and then test it, find out what's wrong with it, model it again, 3D print it, test it, find out what's wrong with it, etc., etc. We want to do that in the quick in clay, and then we use our 3D scanner to bring it into CAD, and then we build from that. So it's just everybody's bought into the shape and the feel of a thing prior to it being modeled. And it also helps us kind of, like I said, there's 1,000 things that are happening at the same time, so I'm not maintaining a linear narrative here. By going into clay or using hand sketching, what it does is it forces us not to be thinking in CAD, because one of the risks in industrial design, risks pretty much with any tool, any field, is that there's an incentive to build what's easy for you. And we want to build what's right for the product. In SolidWorks and other solid modeling CAD packages, the easiest thing to do in the world is cubes with rounded corners, and those don't feel good in your hand, and they don't look particularly great, and they're not necessarily very strong. So we want to start off with clay or other things that force us to think away from that, what's easy, and make it what's right. So like when I was doing this seat for a radio flyer tricycle, just started making it out of clay. We knew what their styling language was, what their design language was, and then we built it. We got their approval. I can't remember if we put a kit on this or not. We might have. And then it was a matter of scanning it and then modeling it from there and adding draft where it was necessary in order. I believe these were blow molded, but for whatever process it was, either blow molded or roto molded, of course. We added that detail, but it was all kind of baked in at the beginning in our minds. But as far as how do I model this, I don't know. I didn't really care at the time. I wanted to make it okay. As long as I know I can mold it, that's what the product needs to be. I don't care if I can't model it, because I'm going to learn how to model it. I'm going to force myself to model it.
You mentioned something, Ed, about the design language, that particular customer was using. Could you tell us a little bit more about that? That sounds really interesting.
Brands have identities. Brands have a vocabulary to them. When you're driving around, like I'm not a big car guy. A lot of industrial designers are big car guys. I'm not, but I can tell a Jeep. I can tell a Chrysler. I can tell a Ford. I can tell Tesla's really good. And it's not because I've memorized them at all. It's just that they have certain design cues that they use across their line. And I don't need to be able to read the badge to identify them. There are other car manufacturers I can't tell, like I can't spot a Hyundai based on its profile or its grill, but that's an example of design language. Radio Flyer has really started, I was working with them probably 2004, 2005. They decided to get away from the big red wagon and getting away from some of the wood products and just go to town on some beautiful industrial designs. And they even brought in car stylists. And when you look at a Radio Flyer wagon, you could tell it's a Radio Flyer wagon just because of the design cues. And there's a whole bunch of things. I just don't have any samples handy here.
Yeah.
But yeah, brands want, when they invest in a brand ID, it's fun because you're given a vocabulary and you want to evoke what has gone before, but then also push it a little bit further. So like when we did these for Ideal Industries, some of the details on the handles became a precursor of what was thought to be a design language that they were going to use from there on. Yeah, they'd actually hired another firm to develop a design language for them that was just a series of dots for where you were going to touch. And from a molding standpoint, it's terrible. But this, with the grooves, it indicates touch me here, touch me here. So there's what we call product semantics, where a product kind of tells you how to use it. But that also would be something that if they had adopted it across their line would have been a design language. I don't think they did, but
that's an excellent example of defining that really helps me, and I think helps everybody listening to understand what you mean by that. But it's an interesting topic that I haven't thought enough about, actually.
Well, think about tools. You can spot a DeWalt tool. You could definitely spot Milwaukee on a job site.
Totally.
They all, even though they can be wildly different in shape, there is stuff that is unified across the brand. We actually did a Greenlee job where we designed their toolboxes, not the big toolboxes, but the cases for all the different types of tools that they make. And we dug into what makes Greenlee look like Greenlee. And it turns out it was the big toolboxes. We came up with, of course, dozens of concepts, but the big toolboxes that you see on construction sites that have a strong horizontal element and big green things, that is what they recognize. Man, that is who we are to everybody. So they rolled that out across the product line.
Very interesting.
So that's brand ID.
Well, I still can't get over the fact that you guys are actually creating models out of wax. I mean, I remember, watching videos years and years ago of the auto manufacturing's doing that. And I thought it was a lost art, but obviously it isn't. And that's just a fascinating story.
Yeah, my partner, Gene DiMonte, talks about that very well. It's like, when people ask us what new technologies are we using, and to some extent, what our new technologies are old technologies, because they're faster and they get you more answers more quickly. Now we'll do a combination, like we won't just in general start sketching freely. If we're doing an electronics device, we know that there's a certain amount of footprint that's going to be required for the board. Now that footprint can change. It's the surface area that matters for the most part. But we'll start off with that as an underlay, and then we'll hand draw on top of that. And that's how we can bang out 20 sketches in 20 hours. And they're all at least relatively accurate because we're combining something new-ish. I mean, CAD's been around for for quite a while.
Long time.
Yeah, but sketching's been around for longer, and sketching is not going to go away because it's quick.
Just another example of why I could never be a consumer product designer. In the same manner that I couldn't learn how to use properly use the surfacing tools, I couldn't hand sketch something to save my life. It's, thank goodness for T-squares and rectangles and CAD.
Yeah, they have their place. They're good. I still have, I don't have my T-square anymore, but man, I still pull out my 30, 60, 90 triangle.
Richard, you didn't have a French curve laying around or anything?
I mean, that's the thing. I could certainly use a French curve, but without that side of the brain, that artistic side of the brain,
totally
even with the proper tools. And, I've used multiple CAD systems. They all have the proper tools. You just have to know how to use them properly,
That's fair.
And that's one of the things that I struggled to pick up. I can fly through a mechanical design, give me big chunks of steel and socket head cap screws, and I'm a happy guy. But, when it comes to what looks good, what feels good, I just don't have that side of the brain. And I'm glad that we have folks like Ed in this world that do. So,
well, maybe to help you out, like, what would be something that an aspiring surface modeling type person should look at or learn, when they approach CAD for this kind of work, beyond the clay stuff and, getting in the CAD. And you mentioned that you'll take a scan and bring that in and use it as a reference to kind of help you get started and things like that. So how would you recommend getting started in surfacing for somebody that's new to it?
Don't think in features.
Okay.
That's a big one. When people are starting off, all the training is you start off with a cube and then you add fillets to it. So that you start thinking about, I'm going to build things up with blocks and I'm going to use fillets to blend everything together. That's a mistake. What you really need to do, and that muscle you need to develop and exercise the most, is understanding what shape really is. And you'll see that, I don't know if it's going to show up very well here, based on the focal point. Like after I sculpted this, you can see there's light lines scraped across it. And the reason for these lines and for everything I've drawn on here is I'm trying to understand exactly what the shape is that I actually made. Where does this, there's a more of a, almost like a chamfer, there's an edge here that then fades off into nothing, and then it's got a round profile through this area. Unless you recognize that, you can't plan ahead or really figure out, okay, how can I model this? And that all happens before I even 3D scan it. It's where I'm really dissecting the shape and trying to figure out what it needs to be. This started off as a wood spoon that were wood spoons. So there was a whole bunch of them that were being hand fabricated, and had to try to figure out, okay, what is this shape? We've got an edge, and then it's transitioning off into something that's not round in this area. It's got a flat top, and then it's round on the underside, and then it transitions here where it's rounder at the top and flatter on the underside. And you have to recognize all of those nuances as you're going through a shape. You could look at, I remember this way back, it's like 2000. friend of mine where I was working at RTC, and I were both experimenting with modeling the new VW, or what was the new VW in 99 or 98. And he was just looking at it as a series of revolves, but it isn't. If you ever get stuck in traffic behind one, if they're still around, I don't even know. That rear trunk, it starts off with an arc, and then when it hits the bumper, it's almost straight across. And that's understanding shape. You can't get to where you want it to be or where it's supposed to be until you understand the shape.
Yeah.
So when Fiskars came to me with a Ren foam model of this, they didn't know how to model it. And I love them for that. That they're like, we don't know how to model it. We just know that the guy who sculpted this is what it's supposed to be. And sure enough, I started off drawing all of these lines on it. And for that, just for the kids out there who want to learn, I use a waterproof or water-based pen. This is what a Pilot fine liner. And what's nice about this is you can draw those lines. And the trick is you want to draw the lines in the direction that you would sand this if you were trying to hand sand it, because that's a direction that SolidWorks or any other program, based on direction of UV lines, and I think they all are, that the UV grid really wants to flow. If you try to violate that, what ends up happening is you're fighting what the natural tendency of the surfaces are trying to do. So you're trying to force something into doing a thing in a way that it doesn't want to, while if you just follow the direction that you would want to hand sand it, everything falls into place really easily.
Mm-hmm. Yeah, what I find fascinating there is looking at the types of geometries. It almost reminds me when I was first getting started in investment casting, I had to do quoting for all these parts, and I didn't have a 3D CAD system at the time, so I couldn't model it up and get the volume and figure out how much material we're going to need for the job. Yeah, just break it down into the plutonic solids, and here's a cylinder, here's a here's a fillet, and then do the math and come up with it. And it kind of feels like you're looking at things, identifying what kinds of geometries are going to be available, and then taking action from there from the clay model, which I find fascinating. It's very nice. Yeah.
Well, it's always easier to break bigger problems down into smaller problems, like you said, when trying to quote an investment cast part. I've done similar stuff when trying to quote volumes on things. Same deal. Well, this block's about the right size, and that block's about the right size, and well, here's about what your surface area is, and to get somebody some rough numbers before we do anything, because if they have a tight budget and they're asking for something that's going to cost $10 that they can't make for less than 12, I want them to know that as early as I know that. And I don't want to get into a situation where they're $10,000 into me doing design work and then come to them and say, no, shouldn't have invested this at all. Because our what we want to do is we want to treat everybody real fair, because we have a 94% repeat business rate. We want people to keep coming back to us and recommending us, because we're not afraid of telling people what they need to hear, even if we don't make any money off of it. We want everybody to do better, because it helps us out in the end too, but also helps everybody else out. It's a good place to be.
Absolutely.
Well, years ago, Ed, you tried to help me out when I was trying to learn surfacing, and I really appreciate that. And I'll still apologize for failing at that venture. But you know what? I think maybe this interview has given me a little impetus to go back and give it a try again. So this time I'll buy my own calipers, and if I'm successful, maybe I'll gift them to you in this case.
Thank you,
Michael. Anything else for Ed?
This was, a lot of good information. I always love to figure out what the origin story of people are, why they got into this world. I know we only have 2 minutes, but what was the thing that made you interested in getting into this field?
I was bred for it, turns out. I was trying to push it back against it. Both my parents are professional artists. My dad is a sculptor. Well, he started off as an industrial designer working for Masonite Corporation. He got laid off from Masonite in the 80s when everybody was getting laid off. He'd already been doing sculptures on the side and decided to make a go of it. And he's extremely good at both. Fun fact, I have recently hired my retired father for a job, and he's working for us. He's really killing it. He's doing a great job.
Nice.
And my mom's still out doing paintings. If you ever fly through Midway Airport, you can see a large installation of hers.
Oh, wow.
Now, I pushed back on that. I'm like, oh, I don't want to follow in anybody's footsteps. I had a strong interest in sciences, so I started off as a physics major. But frankly, DiffyQ killed me. And at this time, I was doing artwork for the fraternity I was in, and found that I really enjoyed that. But I also really enjoyed building things. I'm like, darn it, yeah, industrial design is the place to go. It was years later that I found out that my lineage going back multiple generations. They're all artists or engineers.
Yeah.
So
Totally.
Yep,
yeah,
great family tree. Yep.
at some point, there's just no denying that this is, and I'm good at it. So that also makes it easier to fall into a gig.
That's awesome. That's awesome.
There's no doubt about that. Well, Ed, we really appreciate you coming on and talking about the design process and surfacing and just being here in general. It's been a long time since we've seen each other, and I'm happy that we were able to connect here.
I am too. I always like you, Richard. Thank you for reaching out.
Thank you, Ed. I appreciate that. Feel free to stick around. We've got our tech tip coming up, and then our model of the week. But you're more than welcome to hang out with us.
All right. Thanks.
All right. See you around.
Take care.
Yeah. Good to, very, very impressive advice.
Yeah.
From there. And it's obviously in this DNA.
And I still feel bad that I didn't really get to learn the surfacing the way I wanted to, but I've learned a whole lot of other things from Ed. Just when it comes to life in general, really smart guy. I really respect him. So,
yeah. Well, let's talk about our tip of the week.
Ooh.
And we have my friend and colleague, Jake. How do you pronounce your last name? I always say it wrong, Jake.
It's Delano. I'll just accept anything at this point, though.
Delano. Okay.
We'll just call him Jake. Welcome to the show, Jake.
Jake is a long time. Well, we're all long-time PTC people now, but you've been at PTC for quite some time now, and you've joined the Onshape team, a year or so ago now, and you've been part of our technical services team, and you give a lot of demonstrations and help people figure out all the cool things that Onshape does every day. And we're lucky enough to have you on to give us the tech tip of the week. So, yeah. Which tech tip is it today?
It is my custom frame profile tech tip. So
nice.
We released our frames functionality a couple months ago, and I think it's time we start getting some tech tips out there.
Absolutely.
So we do have the functionality to add in, hundreds of hundreds of pre-made profiles that are in the tool already. But, maybe people don't know that we have the ability to add a custom profile in there as well. So if you're working with some kind of custom 80/20, or even just something that you just generally need to cut, you're going to be using the same profile over and over again. You want to know how long you need to cut it for. You can go in there and create a profile, whether it's from a handmade sketch or something that you're creating from a DXF or a DWG and bringing it to Onshape. And then you can use it to build those frames, make a cut list, and finish up your designs.
Right. What are some of the more common, frame profiles you'll hear customers ask about?
We hear varying things. I did mine based off of the SysPro 80/20 profile that we have.
Yeah, they're all baked in, right? The Onshape catalog has the 80/20, the 10/10 profiles, the 10/20, all those stuff, right?
Yeah. And I guess when people come with custom needs, I'll generally have them, they'll be wanting something to put in a frame, and they're asking about cut lengths, and maybe it's just not a typical frame profile. So that's usually where I'll go with it. And honestly, people have been really happy about it. This was a long asked for functionality, and it's really been a game changer since we've added into the product.
Yeah. I think your tech tip does a great job at showing how you can take this profile, whether you draw it yourself or import it, and then tag them so that they have all the metadata attributes that you'll need for that cut list later without having to manually kind of do work to get it right. So it's a really nice process that's kind of baked in. You don't have to do any weird stuff to do it. It's just part of the software now. So
Absolutely. And honestly, these tech tips are just fun to write. We know so many tips as tech services engineers that we'll throw out here and there to people on calls, but it's nice to get it out for the world, especially, there's so many that you and the rest of the more tenured Onshape people have written that I've just thrown out to customers here and there to help me out on demos. So getting this out there is helping the team and it's helping the people using Onshape.
Yeah, absolutely. Yeah, Frames has been one of the great functions that we released recently. Machine designers and anybody doing fixtures or things like that, they've been clamoring for that. So you can find this tech tip and more on the tech tips page. Just Google Onshape tech tips, or just go to this link that you see right here, and you'll see a whole bunch more of those tech tips that Jake has mentioned. So definitely make sure to do that.
Yep.
Jake, thank you for joining us.
Awesome. Thank you for having me, guys.
Thanks, Jake.
Right. Maybe we can bring everybody back for.
Actually, we've got one more thing.
We've got one more thing. That's right. We have the model of the week.
The model of the week. And, I went searching for something like this specifically, since we were talking about consumer product design and talking about surfacing. And this is a great example that somebody can use. This is a public document. We'll put the URL in the show notes there. But this is a good example for somebody that can go through and go feature by feature, surface by surface, curve by curve, sketch by sketch, and kind of see Nacho's approach to how he designed this surfboard. And I think that's one of the best ways to learn how to do something that you're not familiar with, is to check out somebody else's work and see how they did it. Especially somebody that's got the background and the skills that Nacho has. So,
he was a great designer. It was like one of his first things that he designed when he came to the Onshape team, and it was pretty quick for him to pick up on it and do the layout based sketches, and then get the surfacing filled out the way the board needed to be. So it's a good model. We'll put a link to it in the show notes, of course.
Yep, and that's our model of the week.
Excellent.
All right, Mike, now we can bring everybody back.
Yeah, let's bring everybody back to say hi and wave to the camera. And hey, Ed, you're still there.
Yep.
All right. Well, I really do want to thank everybody for joining us here. It's always nice to give a little wave. So we'll have a little screenshot at the end. So on three.
Hey, well, actually, real quick, Mike, let me just mention one thing. We need to get folks excited for the next podcast as well. We've got a show coming up where we're going to be highlighting some of our Onshape content creators from YouTube, and we've got a really special guest that I'm not going to give away here. You'll have to watch the podcast when it comes out. So,
yes.
And with that, now we can do our little wave.
All right.
Thanks, everybody.
See y'all later.